Hey guys, today we are going to learn 3.5 derivatives of trig functions. So get out some paper, let's take some notes, and here we go. So today we're going to take a look at the derivative of sine. Okay, so what we're going to do is we're going to use a table of values. And we're going to consider the slope at various points. So if we start out at negative pi, and notice that my scale is going to go from negative pi to pi. Okay, here we're at 0. Well, we are going to approximate the slope right here on this yellow highlighted point. So if we take a look at that and we laid a tangent line next to there, we can tell the slope should be negative, and I'm going to approximate that slope to be negative 1. Okay, well, let's take a look at another point. Okay, notice here when I did this slope of negative 1, that slope is another word for derivative, which I need to get my pen going. Here we go. So I'm going to write derivative up here. There we go. And so what I've done here is I have at negative pi, the slope is 1. I've put that there. That's going to be our y value of the derivative. Now let's take a look at negative pi over 2. The slope, I have a nice little horizontal tangent there of 0. Notice that that y value, or that slope, has gone up here to make the point for the derivative. And I'll continue that way with at 0. Slope looks to me to be positive. Positive, I'm going to estimate 1. So here's my 1. My point popped up here at 1, and so now you can see the derivative is starting to take shape. Okay, estimating the slope at pi over 2 would be 0. And there goes that point. And then estimating the slope at positive pi, I would say is about 1. Or excuse me, negative 1. Okay, so here I have my different x values, or theta, since we're looking at sine of theta. Okay, I have approximated the slope at various points along the graph. Those are my y value columns. Okay, those are also going to be my y value for my derivative. Now if I connect the dots, there you go. So if you had to guess, what does that look like? Well, I agree. Most of you are probably thinking that looks like a sine curve, and you're exactly right. Here's your first derivative. The derivative of sine is cosine. Okay. All right, we can do the same thing for cosine. This time I'm going to go a little bit quicker. I'm going to choose negative pi. Okay, I've got a slope of, it looks like 0, horizontal tangent. If I choose at negative pi over 2, I've got a positive slope of 1. Again, notice those y values snapping on the grid. At 0, I've got a horizontal tangent, so slope of 0. At pi over 2, I've got a negative slope, so negative, looks like probably 1. Okay. And at pi, horizontal tangent, so slope is 0. And I connect the dots. So this time, what does that look like? Well, it's not a sine curve, because a sine curve goes up this way. So what is this curve? Yep, you're right, if you guessed it. The derivative of cosine is negative sine. Notice that we have a reflection about the x-axis. Okay, so you have two derivatives. You have the derivative of sine and the derivative of cosine. Well, let's check out the derivative of tangent. So we are going to prove the derivative of tangent by using the quotient rule. Okay, well, if you think back to pre-calc, tangent is the same as sine over cosine. So I'm just going to rewrite tangent as sine over cosine. Now I'm going to take the derivative of that using the quotient rule and what I just learned about derivatives of sine and cosine. So, square the bottom, bring it up. Derivative of the top is cosine minus, leave the top alone, derivative of cosine is negative sine. Well, when I clean it up, I get cosine squared. Negative times negative makes positive. Okay, so think back to pre-calc. Cosine squared plus sine squared is the same as 1. And 1 over cosine squared, well, what is 1 over cosine? Yeah, 1 over cosine is the same as secant. So 1 over cosine squared is secant squared. So here's your third derivative. The derivative of tangent of x is secant squared. We could continue and do the same thing for all of our trig functions, but to save time, I will tell you this is what you need to know. Okay, we just showed through the graphs the derivative of sine and cosine. We proved the derivative of tangent. And in the same way, you could prove all of these. With the derivative of cotangent is negative cosecant squared. The derivative of secant is secant tangent. And the derivative of cosecant is negative cosecant times cotangent. So now, in addition to your polynomial rules, your product rule, quotient rule, I have now added 6 more derivatives. So if you're thinking that it might be a good idea to start making some flashcards, I'm with you. That's a good idea. Okay, because this is 6 of probably 20 more that I'm going to give to you. On Monday, I'm going to assess to see if you know these 6 derivatives. I want to know, have you learned the 6? So have a great 3-day weekend. Sorry I missed you guys today, and do your homework on the calendar. Bye, guys.